Okay, so let's start talking about one of the more powerful features of Python and really any programming language in general, which are functions. So far we've learned a lot of table operations. We've learned how to take the mean or the median of a column, how to find the largest number, so on and so forth. And we've been restricted to using the stuff that is existing, whether it's built in to Python, like the max, min, or sum functions, or whether it comes with NumPy or pandas. But what if we want to do something custom, something that isn't included in these libraries, and we want to do that thing over and over and over again? So for example, we have a bunch of strings. We have a table with a column consisting of names, first and last name, and we want to extract just the first name. Like for example, we want to extract Tony from Tony Hawk. How do we do that? Well, there's no built-in function really that does specifically this. We need to write a little bit of code to do it, which we kind of actually already know how to do from the labs. And then we want to do that repeatedly. So what we're going to do is we're going to make our own function, give it a name, and make it easy to call so that we can repeat this over and over and over again. Here's an example of creating our own function. So maybe what we want to do is, given a list of numbers, we want to calculate the spread. The spread is the difference between the maximum number and the minimum number. So for example, in this data set here, the spread is the difference between 121 and 20, which is just 101. There's no built-in function to do this. If we know how to compute it, we can write a little bit of code. It's just take the max, subtract the min. It's not too hard. But if we want to do this over and over and over again, it would be handy to have a function that would do this. Well, it turns out that in Python, we can create our own functions, just like in any other programming language, really. So here's how we do it. So first, we're going to give it a name. We're going to call it spread. We say def, that's short for define, def spread. And then this will be what's called an argument. We'll talk a little bit more about what these things are called here on the next slide. So don't worry about this too much. I'm going to define, give this function a name, tell it what it needs, values, that's just a name. And then we write a bit of code which computes the spread. Here we take the max of the values, subtract the minimum. And then we're going to return, this word here, return, says we're going to give this value back. So I've defined the function here. Now I can call this function and it'll carry out this piece of code and give me my answer. Now, the nice thing about functions is that they're reusable. So I can change the numbers here, call the function again, it gives me my new answer. So functions are clearly very useful. We're going to write a few of them in this course, and you're going to write a bunch of them down the line. But let's take a look at how functions are defined and learn about some of the pitfalls that we have to keep in mind. So here's sort of the anatomy of a function, the names and stuff. So this is the same piece of code that we wrote on the previous slide, which defined the function for computing the spread. First of all, when I'm defining a function, I start by writing def for define. I give the function a name. It can be pretty much anything, any valid variable name. Okay, so I'm calling this one spread, but I could have called it my favorite function, whatever. Then I write parentheses and then give it a list of names for arguments. So we've seen that functions that we've used before require arguments. They require inputs. Now I have to specify what inputs I'm expecting, and I want to give them names so I can use them later. So in the case of spread, I only need one argument, a list of numbers or a list of values. And so I can give this argument a name. Any valid variable name would work. Here we called it values. If I have multiple arguments, I'm going to separate them with commas, but we'll see that in a few slides. So for here, I just have one argument. I finish my list of arguments with end parentheses, and then I write a colon. And that says, here comes the description of what the function does. Now, within the function, I have the function, what's called the function body. And it's the piece of code that carries out the function. Okay, so I think of functions kind of like a recipe. It's a bit of code that I can execute over and over and over again. This in the body is what is going to be executed over and over and over again. So I have here the piece of code that we're going to evaluate. Notice I'm making reference to the value that was passed in, or the argument. I execute this code. That produces a value that I want to return, that I want to be the result of calling the function. To pass that value back, I have to include this return keyword here. So I return the bit of code. Now, this function here just has one line in the body, but in what follows, we're going to see that functions can have many lines. They can have as much code as you want within the body of the function. The last thing to note here is that this thing, the return or the body of the function in general, is indented. Okay, so tabbed over by 1. And that's very important. In Python, white space, the tabs, the spaces, all of these things are meaningful. They're important. So you have to tab this over by 1 so that Python knows that this is where the body is. And it knows where the body starts and where it ends. So let's talk a little bit about how a function works in Python. So as we said, a function just sort of gives a name to a block of code. And what's cool is that we can create our own functions, give them names, and reuse them. Functions, like I said, are like recipes. What this means, one of the implications of this is that I define a function, but the function isn't executed. The body of the function is not run until I later call the function. Okay, so I define a function first, which just says, hey, give a name to this piece of code, but then calling the function is a separate thing. That's whenever I go to actually use the function. It's like writing a recipe down on a note card and then later actually using the recipe to make whatever food you want. Okay, so if we define variables within functions, which we can do, we haven't done it yet, but we can, those variables defined in functions only exist within the functions. I take it back that we haven't defined a function yet, defined a variable within a function. We actually have this variable right here is kind of defined within the function. It'll only be available within the function values. And we'll see that here in a second. Inputs to the function can be of any type, and we don't have to specify what type we're expecting. That's kind of the nice thing about Python. If you've ever programmed in another language like C or Java, you have to specify what type of thing you're expecting. Here we just say, we're expecting something, let's call it values. It could be a list, it could be whatever. Okay, so let's try some of these things out. So here's a function that I'm calling what is awesome. It takes in something, s, and it returns s plus a string, blank is awesome. Okay, this thing here, these quote, 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 returns what is awesome. This is called a doc string. It's just a piece of documentation. This isn't a piece of code that's executed and expected to do something. It's just a little bit of text that is a reminder to us, the programmers, of what this function does. So this doc string here isn't actually all that useful. It just says returns what's awesome. It doesn't really describe too much about the function. But if you look into the code that's in like NumPy and Pandas, they have really long doc strings that explains exactly what they do. Okay, so let's run that cell. What that cell does is it evaluates the function definition. Now, off in memory, there's a variable, what is awesome, and it says this is the recipe for executing this function. So let's call it. We write what is awesome, parentheses, and then we give it an argument, data science. So we'll run this, and we see that the result of running this cell is the string data science is awesome. So what's happening here is that whenever I write this thing here, I write data science. I put that in a string. Okay, the recipe is called. It assigns the value of data science, the string data science, to the name s while this recipe is being evaluated, and then it runs the piece of code. So s here is replaced by data science, and then I do plus is awesome, plus with two strings, concatenates them, and so it returns the result of that, and the result of that is data science is awesome. So that's why I see this down here. So the key thing here is that whenever I call this function, it starts executing this recipe, it replaces s with the value that I've passed in. Now, once this function is done executing, I might ask, okay, what's the value of s? Because remember, up here, s is assigned to data sciences, just the string data science. So now if I take a look at s, what do you expect to see? Do you expect to see data science? Well, if I do this, I'm going to get a name error. It's going to say that S is not defined. That's because, remember, variables that I define within a function are only available within that function. Okay, so if I can hammer this home, I can say x equals 42 up here, call the function, and then I can ask, what is x? It's not defined. It's only available within the function. Okay, notice I have a return here. I have to return. If I don't return, the function doesn't give me anything back. Okay, so I'm just gonna remove the return, run this function, and you notice I don't get anything back. So in order to transmit that data back, in order to give it back to the person who's calling the function, I have to put return in here. Okay. Lastly, let me just try this real quick. See, you notice that if I ask for help on the function that I just wrote, what it tells me is this piece of information here. So I can change this so that it's obvious. Whoops, I removed a quote. Okay, ask for help, and you see I get this piece of information back right here. So whatever you write here is basically like a help string you can think of. It's a piece of documentation. You don't have to include this, but it's useful. So we said that functions are lazy, which means that the code within the function, the body of the function, is not executed until the function is executed. So remember this piece of code here, 4.0 plus s plus is awesome. Let's actually make this even easier, right? So in Python, if I try to execute 1 over 0, I get a 0 division error. Okay, that piece of code doesn't make sense. So I'm going to make a function here that includes this line of code that doesn't make sense. It'll evaluate to an error. But whenever I run this cell, I'm not going to see an error. I get nothing. That's because errors aren't raised until the function is executed. That's a special case of the fact that this piece of code here is not actually run until I call the function. Okay, there's a difference between defining the function, which is what I'm doing here, and calling the function. So I define the function there. We know that it's going to result in an error once I run it. Here I'm going to run it, and now I see the 0 division error. Notice that I have no arguments to this function. That's okay. I can have a function which has no arguments. If I do that, I still have to include the parentheses. I just don't put anything inside of them. Okay, I'll kind of contradict what this slide says here, just to give you a little bit more information that most errors aren't raised until the function is executed. I can do something like a syntax error, right, which would be like, this is a syntax error. Okay, that line of code does not make sense to Python. It can't even try to run it. So now if I define the function, it says syntax error. I don't have to wait until calling the function for Python to tell me that this is going to be an error. Okay, but most errors, like 1 divided by 0 and things like that, those won't pop up until I actually run the function. Okay, another very, very important thing, and we see this is a common misconception, so I just want to hammer it home here, is that there's a difference between printing and returning a value. Okay, so we've seen print and return. It looks like they do similar things, but they don't. Okay, so I've defined this function here called foo. It accepts no arguments. Okay, I don't have to pass anything in, and it does two things. It prints the number 77, and it returns the number 42. So I'm going to define this function. Nothing's going to happen whenever I run that cell. Okay, now I'm going to call the function. I'm going to call the function. It's going to return 42. I'm going to save the result of this function in x, and then I'm going to display x. Now, what do you think we see whenever we run this cell? Excuse me. Okay, take a second and think about it. Take a guess. Okay, what we're going to see here is 77 and 42. Now, there's a difference between these two numbers. Okay, 77 was printed. 42 was returned. Okay, there's a difference between what is displayed as in a cell due to printing and the output of a cell. This cell has only one output, and that is 42. It's what I return from my function. But I can print whatever I want. I can print a lot of stuff from this cell. Okay, for example, 77 was printed here. If I want to use a number, this is the key thing, if you remember one thing from this slide. If I want to use the result of a function, I have to return it. I can't print it. Print it just displays it to me, the human, but returning allows that thing to be used by the computer. So I return here, I can save the value of x. I can save the return value of the function into x and then ask what is x, and it says x is 42. Okay, 77 is lost. I don't remember it anymore, but x, or 42, is remembered. So printing is not returning. Usually what you want to do is you want to return the value of the function. That said, printing has a place within a function, especially in debugging. Like if you want to figure out what's going on inside the function, the best thing to do is to add print statements within them. Okay, we talked about functions, or we've seen functions which have multiple arguments, or which can accept multiple arguments. For example, the plot functions, those accept multiple arguments. Your functions can have as many arguments as you want as well. So I want a function here that prints out a greeting to someone. It's going to accept two arguments. It's going to accept your name and my name. And if I define this and run it, you see what it produces is a statement printed to the screen. Hello, Zelda. My name is Link. So from the last slide, remember, this is not the return value of this function. This function has no return value. It is a string printed to the screen. Okay, so we're using two arguments here. Whenever I have two arguments, I give them both names, and I separate the arguments with a comma. And now I can use those arguments within the function. To call the function, of course, I supply the values of the two arguments and separate them with commas. One quick note, I said that the return value of this function is nothing. There is no return value. That's not 100% true. If you ask it to save the result, x, okay, and now I try to display x, I don't see anything, but it turns out that if you were to ask what's the type of x, it's going to say none type. Okay, so whenever you don't return something from a function, actually what's returned is none. But that's just a bit of trivia. We don't really need to know that for this class too much. Just keep in mind that if you're trying to return something from a function, you need to have that return in there. Okay, so let's try to implement that function that we talked about at the beginning of this section. So I want a function that returns someone's first name. So I give it a string, like Barack Obama, of a first name and a last name, and I want it to return just the first name. Now we've seen how to do this, I think, in lab. If I have a string like Barack Obama, and I want to get the first thing in it, what I can do is I can split that string using the split method. And if I use the split method on strings, it returns a list. It splits the string by white space, for example, a space, splits it into its parts. And so now I have a list of these two things. If I want just the first name, I can get the first thing using square bracket notation. So square bracket 0, and that gives me the first name. So if I want to do this over and over and over again, it's helpful to give a name to the function, to give a name to that piece of code. It's useful for two reasons. First of all, it allows us to forget exactly the details of writing this piece of code. Second of all, it gives an easier to read name. So it's easier to understand what happens if I call this, for example, first name of Barack Obama. It's going to give me the first name back. Then taking a look at this and trying to remember what this piece of code does. So let's define the function. Okay. When defining functions, what I like to do, here's how I like to write functions. So let's get rid of that function definition here. The problem with writing a function, right, is that the code inside the function is not executed until you call the function. For simple functions, this might be okay, but whenever you're writing more complicated functions, what happens is you'll end up writing some code, a lot of code, and there will be a bug inside, an error, and you won't know until you run the function. And that's kind of annoying because then it's hard to go back inside and look inside the function and see where the error is, because remember, variables defined inside the function exist only within the function. So you can't check those variable values. So here's how I like to do it. First of all, I like to just define my variables, the arguments here. So for example, I'll have one argument called s, and I'll just give it some value, a test value, while I'm writing my function. And now I'm going to write the body of the function here. I'm not going to write def just yet. I'm just going to write the body of the function. So remember, I can do s.split and then 0, and then I can see the result. And then I keep writing the function this way. If it has more lines of code, like I might save this as x, and then like keep going until I get to the point where I have something that I'm ready to return. Now, if I just write return here, Python's going to yell at me. It says it's a syntax error. That's because I'm not within a function. So all I have to do now is that I've written my code. I define my function. I call it first name. I give it the variable. I'm going to call the variable s because that's what I did up here. And then I indent so that everything works. And now I define that. And now I run my function, and it works as I'd expect. Now I can get rid of this. I don't need this up here. In fact, it's completely useless. It's just, all it does is confuse me. So with that, I define the function, run the cell, run the function, and everything's good.